Okay, on 15, we have an initial value problem. A second order ODE, y double prime minus y prime equals e to the t cosine of t. We're given the initial values y of 0 is 0 and y prime of 0 is 1. So we're going to start solving this by applying the Laplace transform to each term. And I wrote some transforms over to the right. I'll write some more. The Laplace of y prime is s times y minus y of 0. Laplace of y double prime is s squared y minus s y 0 minus y prime 0. I think that's all I need for right now. So I have my Laplace of y double prime. That's going to be s squared y minus s times y of 0 minus y prime of 0. I'm going to put that in brackets. And then minus y prime, the Laplace of y prime, is s times y minus y of 0 equals e to the t cosine of t. So this one is our shifting theorem. And that e to the t is going to give us a shift in s. So I'm going to get the Laplace of cosine of t. And then once I write that down, I'm going to shift the s to s minus 1. My coefficient here is a positive 1. Okay, so let's see what we know. We know y of 0 is 0. That's going to cancel this term out. That's going to cancel this term out. Y prime of 0 is 1, so I have a 1 there. Notice that my y terms on the left side of the equation, I have 2. And so I'm going to combine those y terms together, s squared minus s times y. And I also have this minus 1. Everything else cancels. And on the right side of the equation, the Laplace of cosine of at is here. I have the cosine of t. So a is 1. That's going to give me s over s squared plus 1 squared, which is s squared plus 1. I'm going to solve for y. So I'm going to bring that 1 over. That'll give me s squared minus s times y equals s over s squared plus 1, and then plus 1. And I think I'll keep that one separate. Too many partial fraction decompositions to do. So I'm going to combine these terms on the right side. That 1 gets multiplied by s squared plus 1 over itself. And so my common denominator on the right side is s squared plus 1. And then my terms, multiplying by 1, just still gives me s squared plus 1. And I'm going to have that plus this s. So it's going to give me s squared plus s plus 1 over s squared plus 1. And in that coefficient of y, I'm going to factor out an s. And so when I solve for y by dividing by s minus 1, that puts factors of s minus 1 in the denominator of this fraction that I have. And it gives me y. Y equals s squared plus s plus 1 over s squared plus 1 times s minus 1. Our next step is going to be to take the inverse Laplace of this. But with those 3 factors in the denominator, to do the inverse Laplace, I would want to break this up into the sum of 3 fractions. I'm going to have a s plus b over s squared plus 1 plus c over s plus d over s minus 1. If your denominator does not factor, and if it's if you have a power of 2 in the denominator, then the numerator term has to start with 1 degree less than that, so a power of 1. That's why that s squared plus 1 in the denominator, it's got as plus b. You have to start with 1 degree less. Okay, so here, and I'll try to do this off to the side. I think I have enough room. I'm going to just do this partial fraction decomposition. I'm going to multiply through by the common denominator, and that's going to cancel everything from the left side, from the denominator. On the right side, I'm going to have as plus b, and the s squared plus 1 I already have, so I need an s and an s minus 1. For that c term, I have an s. I need an s squared plus 1 and an s minus 1, and I'm out of space on the right side. So with my d term, I need an s squared plus 1 and an s factor. So we either want to simplify the right side and then combine all the like terms, or we want to use the shorthand method to solve for a, b, c, and d. With all of these terms, the shorthand method might work out better. With the shorthand method, we're going to let s equal, and I'm going to start with 0, because that's going to cancel out my factor s. And when s is 0, the left side of the equation becomes just 1. You get 0 squared plus 0 plus 1. On the right side, this first term contains a factor of s, which will be 0, so that drops out. Same thing with my d term. It's going to drop out because it has a factor of s, and s is 0. So it's going to leave me with the c term, c times, and then 0 squared plus 1 is 1, and 0 minus 1 is negative 1. It's going to give me negative c is equal to 1. So I know that c is negative 1. That worked out really good. So let's try it again. This time we're going to cancel out the s minus 1 by letting s equal 1. It's going to be a little bit more trickier because now my terms don't become zeros. On s squared plus s plus 1, I'll get 1 plus 1 plus 1 is 3. On this first term, on the right side, this will drop out because I have a factor of s minus 1. S minus 1 is 0. Same thing with that c term, drops out. And it leaves me with this d term. So I get d times, and when s is 1, I get 1 squared plus 1 is 2. And then s is 1. So I get 2d equals 3. That tells me that d is 3 halves. Just divide by 2. So now I just need my a and b. So the a and b term, we have an s and an s minus 1. And notice that other factor, s squared plus 1, won't ever cancel out. It's never equal to 0. So at best, we're just going to get an algebraic equation here. We're going to get terms. So I'm going to choose s equals negative 1 because that'll keep my numbers small. And let's see what we get. When s squared is negative 1, when s is negative 1, s squared is 1, s is negative 1, so those cancel out. It leaves me with 1 on the left side. On the right side, it gives me negative a plus b times 1 times negative, no, times, let me try that again. S is negative 1. So negative 1 times negative 2, that's going to be a 2 times 2, plus C, well, we know C is negative 1, so I'm going to choose that, times S squared plus 1, let's see, negative 1 squared is 1, so 1 plus 1 is going to be 2, and negative 1 minus 1 is going to be negative 2, and then plus D, and we know D is 3 halves. And then S squared plus 1, again, that's 1 plus 1 is 2. And then S is negative 1. So this won't tell me what A and B are, but it'll give me a relationship between the two. I'm going to simplify here to get negative 2A plus 2B. Then all of this term, that's 2 times 2 is 4. That's just 4. Then this last term, I can cancel those 2's, and I get 3 times negative 1 is negative 3. So this is 1. 4 take away 3 is 1. And if I subtract 1 from both sides, I get 0 equals negative 2A plus 2B. Bring that A over, and it tells me 2A equals 2B, or A is equal to B. So we know that A and B are the same number. And see, I don't know if this was the fastest way to do this, but we know A and B are the same number. So let's just choose one more value for S, and we'll just finish it this way. If S is 2, then on the left side of the equation, I get 2 squared plus 2 plus 1. 2 squared is 4, plus 2 is 6, plus 1 is 7, equals A times 2 plus B. So 2A, and A is B, so let me just replace that with A. So that's 2A plus A, that's 3A. That'll make this a little bit nicer. And then once we find A, we know B, because A is equal to B. So that's 3A here. And then times S, which is 2, times S minus 1, which is 1. So that's times 2. Plus C is negative 1. And then S is 2. So 2 squared plus 1 is 4 plus 1 is 5. And then 2 take away 1 is 1. Plus D. D is 3 halves. Times S squared plus 1. 2 squared plus 1 again is 5. And then S is 2. So from that last term, you can cancel those 2's. And now we can solve for A. We get 7 equals 6A minus 5 plus 15. So this gives you a 10. Subtract 10 from 7, you get negative 3 equals 6A. That tells you A is negative 1/2. And that's B. B is also negative 1/2. So now I know A, B, C, and D, and I can come back up here. So let's see, A and B are both negative 1/2. So I'm going to bring that out to the front, negative 1/2 for A and B, and that's going to leave me with S plus 1 over S squared plus 1. C is negative 1, so I get minus 1 over S. D is 3 halves, plus 3 halves times 1 over S minus 1. So now we're ready to do the inverse Laplace. The inverse Laplace of y is our y of t. And then I maybe should have written this, separated this, the terms from the numerator, but I'll do that now. I get minus 1/2 times the inverse Laplace, and I'm going to break this up into two terms. Well, we'll keep it in one inverse, but two terms. I'm going to break it up into s over s squared plus 1, and we know that's the cosine, and then plus 1 over s squared plus 1. And we know that's the sine, and I'm just going to copy the rest down. Minus 1 over s plus 3/2 times 1 over s minus 1. So now go ahead and solve. Okay, so I have negative 1/2, and then the inverse Laplace of s over s squared plus 1, that's our cosine of t. And the inverse Laplace of 1 over s squared plus 1 is the sine of t. The inverse Laplace of negative 1 over s is negative 1. Then I have plus 3/2. And the inverse Laplace of 1 over s minus 1 is e to the t. So that should be my answer right there.